We're going to determine things with these graphs. We talked about this yesterday. How it ends on the right tells us about the leading coefficient. Listening? How it ends on the right tells us about the leading coefficient. Okay? How it ends on the left tells us what degree it is. So remember, we talked about even degrees, both end up or both end down. And odd degrees disco. So degree 1, degree 3, degree 5. Yes? So let's look at number 1. You tell me, is that a degree odd or a degree even? We know it's odd because it's doing what? Discoing. Okay, cool. What is the least possible degree? Now remembering, I can ask you from 1 to 5. Okay? Is it linear? No, it's not a straight line, so that's good. It's not degree 1. It could be degree 3. This has 1 x-intercept, and this has 1 x-intercept multiplicity. 2. 1, 2, 3, right? So the least degree this could be is 3. It could also be 5, because remember when there's a tangent, I could have multiplicity 2, 4, 6, 8, 10, correct? If this was a multiplicity 4, and this was a 1, then that would be multiplicity 5 total. Not 5. It would be 5 x-intercepts total. And then I would have degree 5, right? Hence why I say least possible degree. So then the multiplicity I'm going to choose for that from the options of 2, 4, 6, 8, 10, 12, 14 is 2. Because it's least. Yeah? So 2 and 1 makes degree what? We talked about this. Degree 3. What's the sign of the leading coefficient? Positive or negative? Negative. We look at how it ends on the right. The x-intercept with the least possible degree, we have x equals negative 4. And x equals 1 what? Multiplicity 2. Because it has a point of tangency. Okay? We have to determine an equation. All right. Can everyone do me a favor? Grab out your calculator. I'm doing a caveat for a second here. For once, you have to let her have her own.
Yesterday I did. For like this second.
All right. This will make you feel like you have to. Same color. But you're going to hand her first.
I don't know, I'm kind of
No, you're going to do it. You're good. How you feeling? All right, we're weaning you off. Okay. So, everyone's paying attention? I will lose you here. If I lose you, you won't get this concept. If I keep you, this is easy and you always get it right. All right. So if we have y equals x plus 3 squared, x plus 3 times x minus 1 squared. I want a smaller screen. I don't want the window to be big. X plus 3, x minus 1 squared. Please type that into your calculator. Okay. Everyone type it in. Zoom 6, in case your window's wonky. Everyone's typing it in. Okay? So we have our, it's not the same graph as before. It's not the equation you have in front of you. This is a random graph I just picked up. Okay? It has an x-intercept at negative 3 and 1 at 1 multiplicity 2, right? A point of tangency at 1. We agree? Okay. Now, what if I do this? Go into Y2 and put that. Make the line thicker. Unless you have colored lines, then don't worry about it. Did your x-intercepts change? No. Did everything else change? Yes. Okay. Take that one out. It's had a negative leading coefficient now because the negative x times x times x, which would be negative x, that's why it's down on the right and up on the left instead of up on the right and down on the left like the other one. It's swapped, right? Okay, clear that one out. I want you to put this in your second one. That one. Okay, everyone paying attention? Did the x-intercepts change? What about the rest of the graph? It got taller, right? It's a vertical stretch by a factor of 3. What's the only thing it doesn't affect? Your x-intercepts, because y equals 0. 0 by 3, nothing changes. Yeah? Okay, we agree with that. But if I just only took into account my x-intercepts, and I didn't solve for this a value, the stretch reflect factor in front, do I always get the same graph? No, I always get the same x-intercepts, but not the same graph. So everyone remembers to do this factor form. They're all over that. But everyone forgets to solve for that. You have to solve for it. Sometimes it's 1. Sometimes it doesn't exist. It's 1. But a lot of the time, your y-intercept's way higher than what you're getting. You'll be like, well, why is my y-intercept way higher than what I'm getting when I just do the x-intercepts? Because you're not solving for that vertical stretch factor. You have to find that first. So let's go back to the actual question we did. Okay? This one has x equals -4 and x equals 1 multiplicity 2. So we're going to go y equals, and I'm going to put an m here. I used to put an a as my vertical stretch reflection factor. I used to do that. But then they give you the format on the diploma. It's like ax cubed plus bx squared plus cx. So they go 1 over a. And then everyone's like, well, my a is this, and this is 1 over a. And you get confused. Just because you made it an a, and they use it 1 over a, doesn't mean those a's are the same. You made an a. You pretended it was an a. So I stopped using a because it's just really confusing. Because they often start with an a, and then it's just like, you think it's the same a as your a, but you made the a. So I did m. Where do I see an m? You could do t. It looks like plus sign. Suggest it? You could. You could do s. Let's go 5. I choose m because it's wonderful. I don't know why. Okay. So x minus equals -4. So I'm going to get x plus 4 as my factor. Now, guys, every time it asks you for an equation, it doesn't matter what form it asks me for. Pay attention. Even if it asks me for a form without brackets, I have to find the equation this way. Then I can distribute those brackets and get it into the form without brackets. That's fine. But I cannot go right to that form. I always have to do this form and then can distribute. So I have x plus 4, and then I have x minus 1 squared. Right? Now, it doesn't matter what science class you're in, chemistry, physics, whatever it may be, science 10. You know that in order to find an unknown, you need to know all the knowns. The rest of them have to be knowns. Every other variable I need to have. I need to know what it stands for to find an unknown, correct? If I have more than one unknown, I can't solve for it. That's the biggest thing in all of physics formulas. You'd be missing one unknown, the rest have to be filled in somehow. We agree? Same thing here. I need to find m, which means I need to fill in x and y. X and y represents a what? Starts with a C. Mine's with a word. Coordinate. Yes, it represents a coordinate. So if I pull a coordinate off of here, that would be helpful, correct? Now this is the catch. Do not take an x-intercept. If you take an x-intercept, it will just cancel everything off, and you'll be like, oh, 0. It can't be 0. M can't be 0. 0 times something cancels the whole equation off. Okay, that wouldn't work. So it can be any point but that. Now on a diploma, I'm telling you right now, they'll bold something. If they don't bold a coordinate on the graph, which screams, here's me, they'll write it into the sentence up top. And people will be like, Mrs. Lepp, you didn't tell me what point. And they'll be like, one of the points on f of x is 1 and 3, but you guys completely ignore all the words because you think they're there for fun. Like they're just there to hang out, but we don't read them. Read them, because sometimes that's where the information is. Okay? So on a diploma, they would have to have, if they bold something, like, so let's pretend that one's bolded, and let's pretend This one is bolded. If they bold them for a reason, right? They're telling you that it's exactly in that spot. Okay? So this one is at 0 and -4. So I'm going to say, okay, I can use 0, -4, and that's my x and my y. Now I'm going to plug them in. So I get -4 equals m, 0 plus 4, 0 minus 1 squared. -4 equals m times 4. -1 squared is 1. Divide the 4 over. M equals -1. And then I get a whole bunch of people boxing that. Is that an equation? Yes. M equals -1 is an equation. Is that the equation of the graph you have above? No. So that has to go into the equation, then box it. So we get y equals -1, x plus 4, x minus 1 squared. And then I just send it. I hope for the best. Or I have a graph above me, which has a window in it, right? I put this into my y equals, change my window to fit the window of that, and then look and see if they're the same, correct? Like I can check this. I have a graph, I have an equation. Okay? Cool. You try the next one. Go. I told you that the curriculum only allows me to ask to degree what? You're listening. Good job. Which means the only even options I have are 2 or 4. 2 looks like a parabola. 4 does not. That's what I say. Okay. I told you, when the arms are in the same direction, even. So these are the same direction, so I know it's even. Does that look like a quadratic? So pretty good chance it's not. Yeah? It doesn't look like that. So I would say it's degree what? 4. Now look, this is 1. This is how many?
3.
Because at the point of inflection through it, there are 3s. 1 and 3 makes 4, which is helpful. So the least possible degree, which it could be, then this could be 5, right? Then that would be 6, yes? So it could, I could just keep going and going and going. So I ask for the least possible degree because then I have to have the least multiplicity, which is 3, on a point of inflection. So it's degree 4. What's the leading sign of my coefficient? Sign of the leading coefficient. Positive y. It's up on the right, and indirectly because it's even, it's also up on the left. Okay, cool. So it's positive. My x-intercepts are x equals -4 and x equals 3 multiplicity. The coordinate I bolded was 1 and 4. Sorry, 1 and -4. That's my x and my y. I'll set up my equation. Y equals a x minus 4. This is -4, isn't it? Was it -4? X plus 4, and then x minus 3 cubed. So then I'm going to get -4 equals a 1 plus 5, 1 minus 3 cubed. -4 equals a times 6. -2 cubed is -8. -4 equals -48a.
How did you magically turn the 4 into 5?
Oh, I math. I mathed the 1 and the 4 together. Earlier, and then I just made it a 5, and then I left it as a 1. You know it's a gift. It's a gift I have. Seeing if you're paying attention, that's what every teacher says when they screw up. Good job. Man, that took a while for you to notice my error that was planned. Mm-hmm. A equals 1/10. Why did I use an A? I said I don't use A's, and then I used an A.
You're just used for paying attention.
Right. Because it could be an A. It could be an E. It could be a P. It could be a smiley face. I wouldn't suggest you not do it, but it could be. So y equals 1/10. X plus 4, x minus 3 cubed. we're going to do a quick flip ahead. We're going to come back to this page after this. We're in the very last page. Then we're going to come back one.
Can we just say 0.1 instead of 1 over x?
Because it terminates, yes. Because it stops, yes. Now the catch is, no, either way would be okay if it terminates. The catch is they might go 1 over a. Guys, shh, Campbell asked a really good question. He said, could we put a 0.1 here? Which is actually a really good question. Because it terminates, you absolutely can do that. However, they might ask for it in the form y equals 1 over a, x plus b, x plus c cubed. What would my a be then? 10. What would my b be? What would my c be? Negative 3. Did you see how this is a plus sign? If the plus here would be negative 3. So you have to watch yourself. Sometimes they say x minus c, and if they did that, then it would be just 3. It matters the formatting. Okay? So we're skipping this page. We are coming back to it, I promise. We're just going to reaffirm what we just did here. So I'm going to give you a physical graph and make you come up with the equation of the physical graph. You can pull the x-intercepts off, all that stuff. Yes? Or I could give you the words of it. So here it says determine the equation with least degree for each of the polynomial functions. A quartic function, what's quartic?
4.
4. Quartic function with 0, 2, multiplicity 3, and negative 5, with a y-intercept of 30. What are they telling me here?
X equals
0 and 30. So that's my x and my y, and solve for m. Go. Have y equals m, x minus 2 cubed, x plus 5. Fill in the 30. 30 equals m. 0 minus 2 cubed, 0 plus 5. 30 equals m, negative 8 and 5. So I get 30 equals negative 40m. Divide by negative 40. M equals negative 3/4. So we get y equals negative 3/4 x minus 2 cubed, x plus 5. Now guys, that is in factored form, correct? Shows the factors of it. Do we agree? Okay, sometimes they ask for the question like this. They'll say, determine the equation of this quartic function in the form y equals ax4 plus bx cubed plus cx squared plus dx plus e. And some people want to fill it right into that. You can't. You literally can't. If I ask you to find an equation, you can be like, thanks, but no thanks. I'm not dealing with you right now. I can't deal with you right now. You are not making me happy. You are stressing me out, equation. No thank you. Then you do it in factored form and you find it just like we did. Doesn't matter they ask for that form. We have to find it this way. Do you understand that? Okay. Now, if they want it in that whole form, I would have to go negative 3 over 4, x minus 2, x minus 2, x minus 2, x plus 5. I would have to FOIL, distribute those, and then distribute in the negative 3/4 left-like terms, and I would have it. Yeah? More often than not, though, they'll ask for it in that form, but they don't want the whole equation. They just want a and e. They often just want the leading coefficient, the value of a, and the constant, the value of e, the one without a variable. Now, the reason why they ask it that way is you do not have to expand the whole thing if they ask for a and e. If they ask for the leading and the constant. If they ask for any of the terms in between, sorry about your luck, you have to expand the whole thing, collect like terms, do the highest degree to lowest degree. It is a lot of work. But if they ask for the leading coefficient, what I can do is I can just multiply my value I just found times each of the x's. So 1x, 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 and I'm going to get my leading coefficient is negative 3 over 4, x to the 4, correct? You see that? So my a in this form would be negative 3 over 4. Do you see that? X to the 4. So you would just multiply the leading number by all the x's. And sometimes the x has a 2 in front of it, so it would actually change it. When would it have like a 2? Well, if your x-intercept was a half, that would actually be 2x minus 1 equals 0. Then you would have a 2, right? So you do have to multiply by whatever the heck's in front of those x's with the leading number. Okay? If they want the constant, if they want the e in this case, the constant, the number without a variable, I take this leading number again, but I multiply it by all the numbers. So I go negative 3/4 times negative 2 times negative 2 times negative 2 is negative 8 times 5 is negative 40. So I would get negative 3/4 times negative 40 over 1. This cancels, that comes to negative 10, and I get 30. So my constant would be 30. Do you see how I can find those without having to expand the whole thing out? If they asked for B, C, or D, sorry, you have to expand the whole thing. There's no way you can go right to this, though. You will always have to do that. Yeah?
Wouldn't the constant also be the y-intercept?
The constant is always the y-intercept. Why is that? When you hear y-intercept, what should you think? X equals 0. So if I put 0 in for all of these, sorry, if this was the constant, if I put 0 in here, and I put 0 in here, and I put 0 in here, and I put 0 in here, those all cancel, right? So our constant is our y-intercept. Leading to the next question. Let's look at it. It says quintic function. Quintic is what? Degree 5. Okay, we got this. Oh, a constant term of negative 12. What did they indirectly give you? The y-intercept. Cole, you just connected those. Good job. 0 and negative 12. X, y. Go. Y equals, it's the third time, x plus 1 squared, x minus 3, x plus 2 squared. So we get negative 12 equals 0 plus 1 squared, 0 minus 3, 0 plus 2 squared. So we get negative 12 equals, I need an M. Come on, Lepp. Get in the game. Okay, 1 times negative 3 times 4 is negative 12. Divide by negative 12. M equals 1. So in this case, had I forgot the M, I would have lucked out. Right? Okay. So I'm going to get y equals 1 plus x plus 1 squared, x minus 3, x plus 2 squared. It's crazy. You want to know what's crazy? Is somehow you guys wrote this down on your paper, and then you highlighted it, and you left yourself a note, and it said, note to self, on exam, everyone forgets how to determine the equation of a polynomial. I'll give it to you in words, or I give it to you on a graph, and they're left blank, or people are lost. Or they try and put it right into that ax4 plus bx3 plus cx squared plus dx plus e formula, which you can't do, right? You have to do factored with an m. Solve it out. Highlight, star. No one is highlighting this. You're not trusting me. This was badly. This is like a really, really easy. Thank you. Thank you, Tyler. Thank you. Thank you, Peyton. Everyone forgets. Easiest questions ever, done terribly. All right, or you can aggressively circle it like Jacob. All right, this one. Okay, I'm going to show you how we graph a graph, okay? How we graph a graph. You might be like, I got this, Lepp. I'm the graphing grapher of all Graphingtons. And then I see your graphs and I'm like, oh, this is the saddest graphs of all Graphingtons, Graphertons. Oh, it's so bad. You guys like put like 3 points on it and then you just let your heart work. You're just like, oh yeah, I think, yeah, this is good too. Oh, I like that. Yeah, that turned out really nice. And it looks nothing like the graph. Or it like slightly does, but it looks like you went over a speed bump in a school bus. True. Or it looks like you did the graph on the table. You guys know what I'm saying? That table is bumpy. All right. So number 1, find the intercepts. 2, check for symmetry. If it is an even function, it's symmetric with respect to the y-axis. If it's an odd It is symmetric with respect to the origin. Use the multiplicity of the zeros to determine the behavior of the polynomial. So if it has multiplicity 2, you get tangent. If it's a multiplicity 3, you get a point of inflection. Determine the end behavior by examining the leading term. Use the end behavior and the behavior of the intercepts to sketch the graph. Ensure the number of turning points does not exceed 1 less than the degree of the polynomial. What the heck does that mean? Well, if it's degree 3, it could look like this. Turning points are maxes and mins. That's 1, 2 turning points, and it's a degree 3, correct? Or it could have no turning points. It could just have a point of inflection. But what it cannot have if it's a degree 3 is more than 2. It has to be 1 less for sure. Like a degree 4 makes like a W, let's say. It has 1, 2, 3, which is 1 less than the degree, correct? So that's what this is saying. And optionally use technology. Wow. Technology. So, let's go here. Before we graph anything, we're going to put things we know. What are our x-intercepts? -1 and 0, or x equals -1 what? Multiplicity 3. What does that tell me at this point I'm going to have? A point of inflection, not inception. That is a movie. Kind of. Give you that. And then we have 3 and 0. Right? What are my y-intercepts? Or y-intercept? How would I figure it out? X equals what, guys? 0. So I could go y equals -0 plus 1 cubed, 0 minus 3. Y equals 3. 0, 3. Okay, can you guys type that into your calculator, please? Go. Sorry. Type the equation in. Okay. All you window people. And by window people, I mean people who think that zoom out is the best option of all options. It's not. So in front of my face, in the -10, 10 window, I currently have something that looks like this. Okay? It's a quartic function. I know that because that's what it would add up to. So it's going like this, and then it's going to come back down. Remember, the arrows have to be in the same direction. So do I have enough? So this is my x min. Do I have to make it any bigger? Or can I see all the stuff to the left? I can see it all, so I'm not changing that. My x max, can I see everything? Coming down here? Yeah. What about my y min? Because I know this is concave down, I know these are just arrows. So do I need to go further down to see arrows that are going to keep going off the light? So I'm just missing that, correct? Which is my y max. So that's all I'm changing. So I go to my window, and I make my y max be 20, and I look. Can I see it all? No. So then, what most people do, oh my gosh, that's like 8 minutes. Then a lot of people are like, hey, I can't see, I'm going to make B. So did 30 help us out? Could we see it with 30? Okay, this has 1, 2, 3, 4, 5, 6, technically 7 blocks. And I need to be able to show something less than 30. Let's figure out what that something is. That is a maximum. Let's go. Second trace maximum. Number 4. Everyone, second trace maximum. Now I need to be on the left side of the maximum. And then the right side of the maximum. And then hit enter. What's it at? 2 and 27. I need to fit 27 y's on there, correct? So my x scale is fine at 1. Remember, your x scale and y scales don't have to be the same. So our x scale is good at 1. We don't need to make it bigger. There are 7 ticks here, and I need to get to 27. what would a good y scale be? 4. Okay. I want to show you, people who think that you can't get any more points than you think you can, because you just go to the table of values, that you can get numerous points. So I know at -1, I'm going to have a point of inflection. I'm going to have a curve through it. At 3, it's going straight through. And I know at 0, 3, I have a y-intercept. Remember, the hardest part of this is remembering that every tick is worth 4. So 0, 3 is 3/4 way up between the first tick, right? Okay. And then I know I have 2 and 27 because I just found it. 2 and 27. So that's my maximum. I'm going to put a little coordinate there for myself. 2 and 27. And then a lot of people wing it from here. That is not even close to enough coordinates. So I want to show you how we can get more. Okay? So let's try -3. I'm going to show you something. So go second, trace, value. And what pops open? X equals. Now I can put whatever X equals I want, and it'll pop out whatever Y I want. Okay? So if I go -3, enter. -48, that's too big. Right? So let's try -2. -2 and -5. Remember, this is 4, so this would be -5. Okay? Now people are like, well, that's all I got, Mrs. Love. Now I'm at -1. You know what's crazy is there are X values that are decimals. It's the craziest thing ever. So instead of going from -3 to -2, I could go -2.5, and -2.5 is at 18.5. So that's 4, 8, 12, 16, 20. So it's like here. Right? Getting a few more coordinates. Yes? What falls between -2 and -1? A whole lot of decimals, correct? -2, -1. So how about -1.5? -1.5 is -0.5625, so it's going to be really close to here. So currently I have this. I'm going to draw a little past that with my arrow. Yes? So I'm working at 0.5s. I'm going 2, 2.5, -3, -2.5, -2, -1.5, -1. I can keep getting points at more points if I want to. So now I'm at -1.5, -1 I already have. Well, what about -0.5? That's 0.43, so that's going to be somewhere like here. Then 0 I already have is 3. What if I do 0.5? That's 8.4. So it's like here. And then 1 is 16. And then 1.5 is 23.45. And 2, try 2.5. 2.5 is 21 point something. 4. Three, and then 3.5 is -45. Well, that's too big. What about 3.25? 3.25 and -19. 4, 8, 12, 16, 20. This one isn't right. This one should be here. So I have 3.25 and -19. So I'm going to go like this, like this, like this. Shh. Do you see how many more coordinates I have than you normally have? Can I even do 0.25s if I really want to be super particular? Yeah. Okay? So it's just using your calculator properly and making your windows proper, and then remembering that when you change your scale to something that isn't one, that you changed it, because I often forget, and I'm like, why is this not working? It's because I know that's a 16, but I thought it was a 4. Sweet. Okay, so you're capable of doing all of your homework now. So